Hello class, I hope you're having a wonderful day. So for the practice problem today, I would like to take a look at an object in free fall. Now, whenever we describe an object in free fall, remember what we're describing is an object that is only being influenced by the force of gravity. Now, in this practice problem, we have an astronaut on the surface of the moon, and so the force of gravity on the moon is much weaker than it is on the surface of the earth, and the acceleration due to gravity on the moon is negative 1.62 meters per second squared. So let's keep that in mind when we're doing this problem. So that's really the only thing that will change in this problem compared to the other problems that we have finished or worked on for free fall. Okay, so let me read the problem and then we will draw a simple picture and start solving the problem. So, an astronaut drops a feather from 1.2 meters above the surface of the moon. The acceleration due to gravity is negative 1.62 meters per second squared. Part A, calculate the velocity of the feather when it hits the surface of the moon. And part B, how long does it take to hit the surface of the moon after the astronaut releases the feather? So what let's do is just draw a simple picture. So here we have you're the astronaut, and you're very happy on the surface of the moon. Okay, so here's the surface of the moon. Here's the feather. It actually looks like a sheet of paper, but let's imagine that it is the feather. Okay, so right here, you're holding the feather, and the initial velocity in the y direction is 0 meters per second. The feather is going to fall to the surface of the moon, so I'm going to identify this velocity, the final velocity. And I'm just going to use a subscript to help describe what's going on. And I'm going to say the velocity, the final velocity, is the velocity when it hits the moon or hits the surface of the moon. Well, we do not know what that velocity is, but we know that the units need to be in meters per second. So we also know the displacement. So change in displacement here is a negative 1.2 meters. The problem tells us that. And remember, displacement is a vector. And remember, a vector describes both magnitude and direction. So right here, when we say the change in displacement is negative 1.2 meters, it's saying that the feather falls in a negative y direction to the surface of the moon, 1.2 meters, so negative y direction. We also know that the acceleration due to gravity on the moon, and I'm going to use lowercase g subscript moon, is equal to negative 1.62 meters per second squared. Okay, and also the time to hit the moon. We do not know that yet, but I want to go ahead and identify that. So, in part A, it says calculate the velocity of the feather when it hits the surface of the moon. So I'm going to use the base equation. Final velocity squared is equal to initial velocity squared plus 2 times our acceleration multiplied by the change in the object's displacement. So we're going to use this base equation. We're going to apply it to our situation. So what I'm going to do is be more descriptive with our variables. So our final velocity is the final velocity that it hits the surface of the moon squared. This is equal to the initial velocity in the y direction squared plus 2 times the acceleration due to gravity on the moon, so g sub moon, multiplied by change in displacement. Okay? Now, the easy thing about this problem is you have already identified the initial velocity in the y direction. It's 0 meters per second. So right here we have 0 squared, that's 0. Let's just go ahead and get rid of this because it goes to 0. So final velocity squared when it hits the moon is equal to 2 times negative 1.62 meters per second squared times negative 1.2 meters. So let's get our calculator. I have 2 times negative 1.62 times a negative 1.2, and this is going to give me 3.888. So final velocity when it hits the moon squared is equal to 3.888. Now let's take a look at our units here. I have meters per second squared times meters, so I'm going to do that over here. Meters per second squared times meters, and algebraically we can write this as meters over 1. So meters times meters is meters squared. We're going to divide by second squared times 1, that's second squared. So right now we have units of meters squared per second squared. Okay, now we're not done here because on the left-hand side of the equal sign I have final velocity to hit the moon squared, and what we want to do is get rid of this squared. We're going to take the square root. Now remember that old algebra rule that tells us what we do to one side we have to do to the other side. So we're taking the square root of this side. Hey, we've got to take the square root of this side as well. Now on the left-hand side of the equal sign, when I take a square root of a variable that is squared, it's going to cancel the square root and the squared, leaving the variable of final velocity to hit the moon. So this is going to equal the square root of 3.888 meters squared per second squared. And remember, not only are we taking the square root of the numerical value, we're required to take the square root of the unit value. Okay, so 3.888, the square root of that is going to be 1.971. The square root of meters squared per second squared is just meters per second. Okay, so final velocity to hit the moon is 1.971 meters per second. But we're not done yet. Okay, because remember, velocity is a vector, and a vector shows both magnitude and direction. So we know that our vector arrow for velocity is pointing in a negative y direction. So any way that we describe our direction, that will be acceptable. So we could say down, we could write down here, or we could show a vector arrow pointing in the negative y direction, or we could say in a negative y direction, or simply we could put a negative sign here to indicate the direction is negative. And that's what I want to do here. So right over here I'm going to say the final velocity of the feather to hit the moon is equal to a negative, because that is showing direction for our vector, 1.971 meters per second. I'm going to box this puppy right here because that is our answer. Okay, so on part B, how long does it take to hit the surface of the moon after the astronaut releases the feather? So I'm running out of room here, so I'm going to erase a little bit. So what we have is our base equation for acceleration. Acceleration is equal to the change in velocity divided by the change in time. So delta V divided by delta T. I'm going to expand the numerator here. So we have acceleration is equal to final velocity minus initial velocity divided by our time interval. Now, we're going to use this base equation here, and I want to adapt our base equation to our situation, so I'm going to be a little bit more descriptive with our variables. So the acceleration that our feather, which looks like a sheet of paper, but it is our feather, it is experiencing the acceleration due to gravity on the moon. Now the final velocity of our feather is the velocity that it hits the surface of the moon. And remember, this is negative 1.971 meters per second, but I'm just going to use this variable right now to put into my equation. So final velocity to hit moon minus the initial velocity in the y direction divided by the time interval to hit the moon. Okay? So in part B, it says, how long does it take? Well, what it's really asking is, how long does it take? The amount of time it takes to hit the moon. So what we're going to have to do is isolate delta t sub hit moon on one side of the equal sign. So what I'm going to do, my first step is to multiply by delta t on both sides of the equal sign, and on the right side it will cancel. So I have delta t, so hit moon. What you do to one side, we have to do to the other side. Delta t sub hit moon. Boom. Okay, right here. Those guys cancel. Next, what I want to do is divide both sides of the equal sign by the acceleration due to gravity on the moon. Okay, so I have delta t sub hit moon is equal to the final velocity that the feather hits the moon minus my initial velocity in the y direction divided by my acceleration due to gravity on the moon. Okay, now let's make a prediction here. Should our value for time be positive or negative? Well, remember that we cannot have a negative value for time. So if we end up doing our calculations and we receive a negative value for time, hey, we've got a big problem, okay? So let's see if our time interval comes out to be positive. It should. So this is going to equal final velocity that the feather hits the moon. Remember, velocity is a vector, so you must show direction. Well, we have a negative sign here. So negative 1.971 meters per second squared minus the initial velocity in the y direction. Well, you have already identified this velocity. This is 0 meters per second. So minus 0 meters per second. And we're going to divide by the acceleration due to gravity on the moon, negative 1.62 meters per second squared. Okay, so let's take out our calculator. Let's take care of this. I have a negative 1.971 divided by negative 1.62. So right here, negative divided by a negative, our negatives cancel out. So we're going to have a positive value, delta t sub hit moon. This is equal to 1.22. Now let's take a look at our units here. So I have meters per second squared meters per second in my numerator, and then we're dividing by meters per second squared. Meters per second squared is in our denominator. So remember, whenever we divide fractions, it's like multiplying by the inverse of the denominator. So what I have is meters per second times, let's do the inverse of our denominator. So the inverse of meters per second squared is second squared over meter. So immediately we can see that our meters cancel and one of our seconds cancels, leaving us with units of seconds. So our answer for the time it takes for the feather to hit the moon is 1.22 seconds. And you notice that our time value is positive, so it has to be positive. So, All right. Well, hopefully us working through this together has helped you today. As always, if you have any questions, I would love to hear from you. Don't hesitate to call or send me an email, or you can message me on Canvas, and I'll get back with you as soon as I can. So, like I said, I hope this has helped you today, and I hope you have a wonderful day.